Okay, so I think it's recording. I'm going to share the screen. Okay, so we should be good. So we're going to go to our virtual machine, right? So we can open up a terminal. And like I said, I'm just going to do 3 tasks here. And then, I've done the task for confidentiality in previous labs. So you'll need to use those openssl commands for that, for the last problem. Okay, so let's open up the terminal. Should be recording. And navigate to the desktop. Okay. Ph.D. And I think, yeah, I had started a folder called integrity hash, so I'm just going to use that one. So I don't have too many folders in here. All right, so I have a plain text file. Basically, now you could do this with encrypted files too, okay? So that's your problem to solve. So let's look at the plain text file. Let's see what's in there first. Okay, so John Smith, this is a secret file that will be encrypted, hashed, and sent to my classmate. Okay. What this meant is when you do your lab, put your name on it, please, so I can see it in the screenshot, right? That your name is in there, the date, something like that. And then also in your lab report, mention who you work with, so that way I'll check both homework assignments kind of together, right? And just kind of see that you guys work together. All right. Does anyone still not have a partner for these assignments? You don't have a partner. You can't work alone, right? So very important that you work with a partner on these things. What's your name? Quentin. Anyone want to work with Quentin? You want? Okay, great. Anyone else not have a partner, guys? You cannot do these assignments. As I said, you just don't understand it at the same level. Okay, if you're just doing it on the same VM, it's not the same. Okay, there's several levels of complexity that you will encounter once you're working with another person. Okay. All right, so seems like everyone's good. So I'm gonna save the file. All right, so like I said, the only thing I did the last time around is I ran the openssl commands for MD5, SHA-1, and SHA-256. And that's really what you need in order for you to hash files, right? So we're gonna basically say here, get the hash of the file with 3 algorithms, okay? And you guys kind of now have a sense of how these algorithms work. Obviously in the class, we're not gonna spend time on every single one of the algorithms. We kind of just looked at a generic one. And then of course, if you guys have an interest in how SHA-256 works at the end of the semester, that can be your term project, okay? If you check the syllabus, that the term project is worth 10% of your grade. So it can be something simple like that, okay? But you'd have to implement it, obviously, is what I mean, the algorithm. All right, so let's just do the hash. So it should be pretty straightforward. It should be openssl DGST for digest is usually the term, and then dash MD5. It doesn't matter to me which algorithm you use for the hashing. It's, anyone is fine. All right, so let's when you do it with your partner. But for these, you do have to try all 3. All right, so plain.txt, right? And there it is. That's the hash value. Pretty simple. You know how to get this because we did the algorithm, so you kind of get the idea. That's hexadecimal values, basically, right? We repeat this one with SHA-1. SHA-1. Yep. And then you can see what happens is the size increases, right? So you can imagine how you could just make the block size bigger, and that would kind of give you similar results. And then you can do, obviously, these algorithms, are not just XOR. Sometimes they do have some additional complexity. And then SHA-256. And as you can see, it's even longer, basically. And that's it. It's as simple as that, right? So that's a pretty straightforward calculation. And we had done this before, okay? Now the next step, so that's basically problem 1, okay, of the homework. This, you just have to do this, okay? So now I won't do all the labs, right? So like starting next week, one of, the lab that you have to do is kind of, you have to be more involved, okay? This was the easy phase of the semester. All right, so now the next thing we're gonna do is the keyed hashes, okay? So we talked about that. So you're gonna try out basically different key sizes for these, just try a few. And just see what happens. If it basically, the question is, does changing the key size affect the hash value? What do you guys think? We've seen, well, if for an MD5 one, for instance. So it might be that the algorithm has a very specific block size, right? That's the output. So it wouldn't really change, okay? But you can experimentally try it out. Do you see that? So that's the beauty of this. You can experimentally try it out and draw your own conclusions. So to do this one, it's very easy. So we just have to add a flag for this. We can still use plain. I'm going to do clear here. And we're going to do openssl dgst -md5. And now we say -hmac. Okay, and that should be basically the key. So you can type pretty much any string that you want in here. So try, for instance, key, the word key, and then you can try plain.txt. Do you see that? And so that's how it works. Let's try for MD5, just a longer key, which basically just say longer key. Try. Okay, and if we do it, what do you notice? Different. It's a different hash, but it's the same size, right? Same block size. Got it? Yeah. That's kind of what it is. And then repeat the exercise for, I'll just do one for SHA-256. Let's do SHA-256, even longer and longer. And of course, SHA-256 gives you a bigger key because it's SHA-256 itself. But let's try 1, 2, 3, 4. And they're different, but they're the same size. Do you guys see that? So that's kind of the conclusion that you can draw from the key. And I leave it to you guys to play with this and add even more, longer, etc. Try different things. Do you have a question? Sorry. Mm-hmm. Oh, okay. Any other questions, guys? Make sense? So that's the second problem, the keyed hash. And now let's look at the third problem, getting the hash of a file. And we're minimally going to change the file and then observe the 2 hashes, okay? Just to see what happens. We can use ghex for this. So this way it's convenient. You could also go into the plain text, of course, and change a letter. But the beauty of ghex is that you can hash an audio file, a video file, something like that. And so you can change at the binary level 1 bit of it. Does that make sense? So we want to use ghex here. Any questions? All right, so this is the third problem here. So pretty straightforward. I'm going to do clear. Okay. And so for this one, what do we do? We obviously need to pick the same algorithm, right? So that has to be consistent. So I'm just going to pick SHA-256 for this one. So let's start with that. Open SSL digest dash SHA-256. Okay. And then plain.txt. Okay, I get that, right? If I repeat it, look at the hash. Are they the same? They are the same, right? Do you guys see any discrepancy or any difference? No, right? Of course, we could write an algorithm in Python to compare both of these, right? And tell us if they're equal. So that would be a thing that you can do. All right, so now the trick is we're going to change just one bit of this. So I encourage you guys to do this with other files, right? And in fact, you do have a challenge in your problem with the partner because I want you to achieve integrity and confidentiality in one shot together, right? So you need to think about that one. All right, so let's now change one bit. So I think we had used ghex in the past. Okay, so that's ghex plain.txt. So it opens it, right? It opens it here, just like we did before. So now you can choose one of these. I'm going to choose this one, and I'm just going to add a D in there, right? So I changed one bit of it. Do you guys see that? You can change it to whatever you want. And then there should be a save button here. We'll save, maybe save as, and save it to corrupted, right? Oops, yeah, that's fine. And hit save. Okay, and I'm going to close this one. So now if I do ls-l, I have my plain and corrupted, right? We can view plain corrupted, right? And you can see here there is something that got modified, right? That's the one bit that I changed, but I changed it in the ghex itself. So now what I'm going to do is I'm going to run both of these, right? So I'm going to first do the hash of plain, and I got that value. And if I do the hash of plain again, I should get the same value, right? And now we know that corrupted, the only thing that's different is that bit that I changed, right? So then I'm going to do open SSL, but now I'm going to like corrupted dot txt. You see that? Hit enter. And what's your conclusion?
Different.
How different? Because they're almost the same thing, except for one bit. Significantly different, right? So that should be your conclusion, that even if you just change one bit of it, the hash value looks very different, like very, very, very different. And that's an important observation to make. Does that make sense, guys? So these are the three problems, okay, that you have to kind of me demoing. And then you have now the last problem to do, which is working with your partner. So that one has been assigned. Again, you create a file. You need to send that file to both of you need to do it, right? So let's say Bob sends a file to Alice, and then Alice sends a file to Bob, okay? And so you need to achieve both Bob and Alice need to achieve confidentiality and integrity in one shot. That means what? You can only send one email. And don't worry about the key, obviously. Got it? Does that make sense? So I'm going to create the assignment. Okay, so that's the part that I was going to demo, as I said. Yeah, please.
You don't want us to do task 4
On the PDF? What does it say? This is all I want you to do, but since you brought it up, let's take a look. We did that. We did that. No, not this part. No. You can skip that. We can come back to it if you guys like. All right. Any other questions? All right, so let me add the link for the assignment. Okay, so I'm gonna add here. New assignment. All right, so this is homework. This is going to be integrity hash, right? Oh, this is due, so today is the 14th, so this is going to be due on the 21st. Like 10 p.m. And it'll stay open until the 24th. All right, so complete. Oh, I don't need, sorry, the video I don't need to do anymore, so I'm going to stop then, okay?